Molecules. Atoms rarely exist on their own. Usually they join with or bond to other atoms. Two or more atoms joined together are known as a molecule. If the atom in a molecule are, are of different elements, they form a compound. Molecules vary hugely in size. Some are just two atoms, such as molecules of the gas oxygen in air. Other molecules have millions of atoms in materials such as wood, plastic, and rubber. Salt crystal. In salt, each molecule has two atoms. One is sodium, which when pure is very lightweight metal. The other is chlorine, which is on its own a greenish poison gas. Joined together, they produce a very different substance, sodium chloride, as tiny grains of crystals. Billions of salt molecules arrange in irregular patterns like tiny bricks to form a pyramid shape known as a crystal. It has flat sides, angled edges, and sharp corners. How atoms join. Atoms join into molecules in several different ways. One is to share the outermost part of the atoms called electrons. An atom of sodium has just one electron in its outermost zone or shell. Chlorine has seven, with a neat space for just one more. So sodium's outermost electron spends some time in its own atom and some in the chlorine atom. This keeps the two atoms near each other. Electrons are negative, so the chlorine atom with an extra electron is negative, while the sodium atom without one is positive. Negative and positive attract or pull nearer, helping the atoms stay together. Some molecules can contain hundreds, even thousands of atoms to make complicated structures. Carbon is particularly good at making complex molecules as each atom of carbon can join up to four neighboring atoms. Most living things are made out of molecules containing carbon. In beans, caffeine is mixed with more than 1,000 other substances, including lactones and phenyladanes, which cause the bitter taste. Carbon. Carbon is the fourth most common element in the universe. Unlike most other elements, it occurs in nature in several very different forms. By reacting with oxygen and other elements, it forms substances essential for life on Earth. It is also vital in our modern world for making all kinds of materials, from the hardest steel to the lightest fiber, and provides many of our main sources of fuel for cars, heating, and electricity. Forms of carbon. Each carbon atom has four links or bonds, which can be slightly different angles to each other. This allows carbon atoms to join each other in different ways to make very different substances. Coal, diamond, and graphite are all pure carbon, but they look and behave very differently because of the way atoms inside them join together. Most forms of carbon are black and fairly soft, but a diamond is clear and is the hardest known natural substance. In coal and soot, atoms are all jumbled up. Atoms in hard diamond are fixed in rigid boxes, and soft graphite has atoms arranged in layers. And this artificial form of carbon is called a buckyball. What is going on? Your carbon sugar snake is the product of 3 chemical reactions that are all dependent on heat. The first of these reactions occur when sugar combusts or burns in the presence of oxygen. This produces carbon dioxide gas and water vapor, also a gas, which pushes more of the sugar/baking powder mixture upwards. Some of this additional sugar heats up but doesn't have access to any oxygen, so instead of burning, it undergoes a thermal decomposition, producing solid carbon and more water vapor. This solid carbon now gives the snake some more shape and also gives the snake its black color. Lastly, the baking soda also decomposes in the heat, producing solid sodium carbonate and carbon dioxide gas and water vapor. Altogether, these 3 reactions produce both the solid components of the snake and hot gases that expand and inflate the snake up and out of the sand bowl. The sand in this experiment doesn't chemically react with anything in the growing snake. Instead, it evenly distributes the heat from the burning lighter fluid to the sugar in the baking soda. To the sugar and the baking soda, ensuring a slow, steady burn and the growth of a long carbon sugar snake.